Yes. Yeah. Good evening, all. So myself, I'm Vijay. Like I hold 20 plus years of experience, which includes around 10 plus years of experience in this Spark and Hadoop. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Yes. What is Apache Spark? Yes. Anyone try to confirm me why my voice is clear, whether the screen is visible or not? What is Apache Spark and why we go for PySpark? Why PySpark? Need for PySpark? Mm. Okay. Spark and PySpark. PySpark features. PySpark features and real life usage, right? A real life usage of PySpark. PySpark job market. Apache Spark. Apache Spark, right? Yes. See, Apache Spark, it is an open, I can define in Apache Spark. Even Spark is a open source. It is an open source distributed distributed cluster computing framework, right? With in-memory computation feature, with in-memory computation, right? In-memory computation means storage and processing both happening within the memory level with in-memory computation in parallel processor style, in parallel processor style used for large scale data processing. Say open source distributed cluster computing framework with in-memory computation feature, right? With parallel process style used for large scale data processing. Spark is a general engine. I can say Spark is a general engine for big data analysis. It's a general engine for big data analysis and computation. Spark is a very high speed. It's a very high speed processing execution model. Processing execution model. Very high speed processing execution model, which process huge data, which process huge data in quick time. It's a very high speed processing execution model which process huge data or big data, right, in quick time. Spark is 100 times faster. Spark is 100 times faster. Normal disk processing. Disk processing. It is 100 times faster than the normal disk processing, right? Yes. So here, if you see, oh, why PySpark? Why PySpark? Simply, PySpark is the Python API, is the Python API to use Spark. Python API to use Spark. So PySpark is one of the lightning fast technology that is designed for fast computation. I say it's a very fast execution model. So one of the demanding tool for the data engineers to work with bigger data sets. So here PySpark used for saying right, running distributed SQL, running distributed SQL. See, Spark data is distributed. Spark data is divided into multiple partitions. That partitions are distributed across multiple systems, and multiple systems will be processing the data parallelly. Data is distributed across multiple partitions. That multiple partitions are stored across multiple RAMs of multiple systems and are processed, and that's why we see very high speed. So running distributed SQL, creating a creating data pipelines. So Spark is a data flow language. It's creating data pipelines. It's a data flow language. The output of one will be the input next. Like in this way, pipe. The output of one will be the input to the next. Like it's creating data pipelines. Ingesting data into database. Ingesting data into database. Running for even for ML kind of things, right? PySpark has got very PySpark is mostly preferred running ML algorithms. There is a separate module provided by Spark ML lib library, right? Spark ML lib library, especially for this running ML algorithms. Not only for that, even we have got separate Spark modules. If we see like the Spark graphics, working with graphs or data stream. So in this way, it's used for running distributed SQL, creating data pipelines, ingesting data into database, running ML, working with graphs, working with data streams. Need for PySpark. So if you see today, like you should have seen KBs of data, MBs or GBs of data or TBs of data. Today data is generating in petabytes. Huge data is getting generated everywhere. So a large amount of data generated through offline and through online, right? So this data contains hidden patterns. This data contains hidden patterns, user preferences, market trends, unknown corrections, and other useful business information, right? It is necessary to extract the valuable information from this raw data. So we need to extract that valuable information from this raw data, right? Yes. So we require an efficient tool to perform this. So we require an efficient tool to perform this kind of operations. So I mean, it doesn't say that it doesn't have tools previously. We have got tools previously, but they were not that much fast in processing, right, as compared with this Spark. So we need to have some scalable and flexible tools to crack this big data and gaining benefit from it. So PySpark is such a kind. So combining Spark and Python. So PySpark, nothing but combining Python and Spark. Python and Spark. So would be the very efficient way for the world of big data. So Python plus Spark. So it's a very efficient. So that's why Apache Spark community came up with a tool called PySpark. Sorry. So they came up with a tool. Apache Spark community came up with a tool called PySpark, Python API for using Spark. Yes. So here, whenever I say Spark, means by default implemented by using Scala language. Spark by default built using Scala language. Spark by default built using Scala language. Whenever we say Spark, means by default implemented using Scala. So whenever I say PySpark, using Python, Spark implemented using Python. So both so this is a Spark with Python and Spark with Scala both mostly used, but previously Scala was used a lot, but now today if you see in the industry, so PySpark, Spark with Python was used a lot because Python has got many modules towards different environments like machine learning, for streaming, for graphics, for all these things, right? So if you talk like Python and Scala, which one to be preferred, right? Python and Scala, which one to be used more? You see the differences between this Python and Scala. Scala is nothing but scalable language. Scalable means extensible. Extensible means it is extension to Java. So Scala. So differences between Python is interpreted and dynamic typed and dynamic typed. Python is interpreted and dynamic typed. Scala. What do you mean by dynamic? Dynamic. So here Python is dynamic typed. Dynamic data types we say based upon what, no need to define the data types, based upon what value you are assigning. Based on the value assigned, the variable gets created dynamically. If you're assigning an integer variable created dynamically. A float variable gets created dynamically during runtime. You give a string value. X is a string variable that is created dynamically, right? So based upon the value assigned, the variables are created dynamically here in Python. Python has a huge community. Python has a huge community. It supports 89,300 inbuilt modules it provides. Python has got huge community. It supports around 89,300 inbuilt modules, but Scala community is smaller. Scala community, right? Scala. Scala community is smaller, and that too Scala used only for Spark. Used only for Spark. No other environment using the Scala language. Python contains powerful libraries. It contains powerful libraries for data science, graph, streaming, etc. Libraries are less compared to Python. But one advantage of Scala over Python is Python is slower compared with Scala. Scala is faster than Python. So because Python is interpreted line by line execution, Scala, so it's faster, right? Yes, it's both compiled and interpreted, right? You see this PySpark features as compared, right? Yes, PySpark features. In-memory computation, right? Yes. Storing and processing. What do you mean by in-memory computation? Storing and processing. Both happens at memory level. Both happens at memory level. Secondly, lazy evaluated. Lazy evaluated. PySpark is lazy evaluated. Lazy evaluated means
Those functions can be executed whenever then dynamically it will be executed whenever is required.
executing the data flow on demand by providing an action. If you provide an action only, it will execute. Otherwise, it won't execute. It's not like which one? Lazy evaluated or active evaluated? Active evaluated means then and there. Whenever you define executing, that is what? Active. Lazy evaluated, not like that. Even though if it is defined, still it won't execute until you make some action. Just like functions in programming languages. You will define functions, but until you call them, they are not going to get executed. Similar to that, right? Yes. Providing an action, right? Yes. Lazy evaluated. Next, partitioning. Partitioning. Spark data is divided into partitions and are distributed across multiple RAMs, multiple worker nodes, and are processed parallelly, right? Partitioning, if there is partitioning only, that's parallelism can have that parallel processing, right? Because your data divided into partitions, partitions stored across multiple systems and are processed parallelly. Yes. One more important feature of Spark, persistence. Persistence, right? Yes, persistence is an important feature. Reusing already executed transformation. Reusing already executed transformation output. No need to re-execute here. No need to re-execute. Reusing already executed transformation output, no need to re-execute. Just reuse. Immutability. Immutability. Spark data objects are immutable. Spark data objects are immutable. They cannot be modified or changed. Fault tolerant. Fault tolerant. Spark has powerful tolerance. Spark has powerful fault tolerance model. Spark has powerful fault tolerance model. Spark has powerful fault tolerance model. Means Spark data is running on multiple systems, right? Spark data running on multiple systems. Means Spark data divided into multiple partitions. The partitions stored across multiple systems and are running parallelly. So if any system goes down, there is a chance of data loss. Data loss, right? So instead of Spark can regain the lost partitions, that everything I'll discuss in brief in fault tolerance model, right? Yes. It has a powerful fault tolerance model. We'll be discussing in brief how it can regain the lost partitions and can execute. So lazy evaluated partition divided into partitions, then only parallel processing persistence already executed transformation output. Can right? Yes. No need to re-execute, right? Immutability, Spark data objects are immutable. They cannot be modified. In-memory computation, the main feature, storing and processing both in the memory level, right? Yes. Real life usage of Spark. Real life usage. Real life usage of PySpark. Real life usage of PySpark means it is used in the commercial sector. In the commercial sector, right? Yes. Apache Spark real-time processing. Banks and other financial systems, they use Apache Spark for retrieving customer social media profile and gaining useful insights which make them to take right decisions. And in credit risk assessments, in targeted and customer segmentations, and in fraud detections, in healthcare, in identifying the patients who is going to face the issue even after being discharged from that clinic. Entertainment industry, the popular OTT platform like Netflix uses Apache Spark for its real-time processing. It is going to process more than like approximate 450 billion events per day that are streamed over server-side application, trade and e-commerce. The leading e-commerce websites like Flipkart, Amazon, all this they are using Apache Spark for advertising and even for enhanced customer experience. And the tourism industry also using Apache Spark to provide b- advice to millions of travelers by comparing these hundreds of tourism sites. When we have got a topic like Spark SQL, it's a model in Spark which integrates relational processing with Spark functional programming. So we can extract the data by using SQL query language. SQL, like you can perform like SQL kind of querying. So the same queries that we used to see in SQL, right? On top here we see the concept of data frames like a tabular structure. On top of that, we'll create temporary tables and perform querying, right? Yes. Yes. If we say motivation towards Spark, I said just like 100 times faster than normal disk processing. You see, Yahoo has conducted a test. Yahoo has conducted a test, right? It has taken a table of 100 TB consisting of 1024 columns. Task task is sorting based on 16 columns. Sorting based on 16 columns. Time taken by it has taken around 3.5 days. It has taken around 3.5 days, right? And MySQL, it has taken around 6 days for handling this huge data. And Teradata, a specialized database used for data warehouse, it has just taken 4.5 hours. Netija, another specialized database that is used for data warehouse, just taken 3 hours. Finally, Big Data Hadoop, it has just taken 3.4 minutes. It has taken 3.4 minutes. Say it has, as compared to this, right? Hadoop has got very less time. Hadoop has got very less time in minutes. These have taken days and hours. Spark is 100 times faster. See the speed of Spark then. Spark is 100 times faster than Hadoop MR. Hadoop MapReduce we say. In Hadoop we have got MapReduce execution happening. So it is 100 times faster. So as compared to that, Spark has got a very high speed. So that's why today in the industry, Spark is mostly used for handling huge data. So Spark is for batch applications. It is for batch applications. Batch applications, we have got online applications and batch applications. Batch applications, right? You, online applications, user interactive applications. User gives the input. But batch applications means millions and trillions of records. Millions and trillions, right? Trillions of records. User non-interactive applications. So for that. So here we'll be seeing as part of the course, we'll be seeing like Spark with Python implementation. So Spark with Python. So Spark can be coded in multiple languages. Spark can be coded with Python, Scala, different languages. Scala is the default language. Default, it was built in Scala. And even Java also. It has got multi-language support. And also like R language. Spark data objects. Spark data objects. Generally Spark data objects. RDDs we say. Data frames we say. RDD. Spark data objects RDD. Resilient distributed data sets. Resilient distributed data sets. And also like DF data frames. resilient distributed data sets and data frame. See, if you observe here RTD, generally how this RTD means Spark data objects are created. Just observe here, right? Understand here? If you are loading using Spark context, if you are loading a text file, so and so file path, where your file is present, so and so file path, RTD1 is created. On that RTD1, on the RTD1, if you perform anything, any transformation like filter, RTD1 dot filter, you filter the data based on particular city or some condition EQ. The result, whatever you get, is another RTD. And whenever you perform transformation on RTD, the result is also an RTD. Remember it. On a RTD, if you perform any on a Spark data object, if you perform any filtering or transformation, the result is also an RTD. On RTD2 dot map transformation, mapping, okay. Add 5,000 to the salaries of each employee. RTD3. RTD3 dot group by. RTD4. In this way, right? In this way, multiple RTDs, right? Whenever you say RTD4 dot action, multiple actions are there. Whenever you say RTD4, then only this entire data flow is going to execute. Entire data flow executes. Where this Spark data, this RTD1, RTD2, RTD3, 4, these are Spark data objects. Where where they are getting stored. Yes, try to respond. Where they will be stored. Where these RTDs will be stored. All these RTD, I said in Spark, storage and processing in the memory level, RAM level, in memory computation, both storage and processing, both happens in the memory level, RAM level. You see, Spark is for huge data processing, means huge data files. Because here, if we talk about first RTD created from this file path, file one, you think file one is a bigger data file, like TBs or petabytes of data. So RTD1 size is huge data, right? RTD2 also has got huge data, 3, 4. All these three RTDs cannot be accommodated in the RAM. All that RTDs cannot be accommodated in the RAM because one RTD size is a very big, huge, larger size. To accommodate one RTD only, it is a big task. But these many RTDs, if you have got a very big flow, like 20 RTDs involved, all the 20 RTDs won't be stored in the RAM. No. Otherwise, that RAM. So what happens here? First RTD1, it is divided into partitions. It is divided into partitions. Each partition stored across one system. They are processed parallelly, and that output of this is taken as the input by RTD2. As input by RTD2. When RTD2 is again divided into partitions loaded across multiple systems, when RTD2 is loaded and computed, RTD1 and its partition, everything gets removed from the RAM automatically. Understand here how this Spark data objects are computed. When this RTD2 loaded and computed, this is going to get removed. Once RTD2 is loaded and computed, right, the output of it is taken by RTD3. Okay. Once RTD3 is loaded and computed, when it is loaded and computed, This entire, this is going to, its and its partitions, everything will be removed from the RAM. Similarly, RTD3 output as input to RTD4. In this way, data flow, Spark is a data flow. The output of one will be the input to the next. When this is loaded and computed, it and its partitions will be removed from the RAM. Once the final output is collected by the client, once the final output is collected by the client, the final RTD, this also gets removed from the RAM. This also gets removed from the RAM. Now, how many RTDs in the RAM? Try to respond. I want the sessions to be more interactive. Everyone, whether your answers are correct or wrong, keep responding. Yes, unmute yourself and try to respond. How many RTDs in the RAM now? Once the total flow is executed, the output is collected by the client. How many RTDs in the RAM?
Zero.
No RTDs in the RAM, right? No RTDs in the RAM. You can trigger the next flow. You can just trigger the next job or the next flow, right? Again, one by one RTDs will be loaded, computed, and they'll be removed from the RAM, because if there is a very big flow of 20 RTDs involved, 20 flows means like a very big flow means one by one RTDs, if they are getting loaded into the RAM, if they are getting loaded into the RAM, right? Yes. Then the RAM cannot accommodate the incoming RTDs, next RTDs, right? So what happens? That once the next one is ready, the previous one gets removed from the RAM. That is what, how this RTD Spark data objects are, how this RTD is created. Whenever you load a file using Spark context, it's created. What second one, how it got created? If you perform any filtering, mapping, or grouping, right, or merging, this one is created. So transformation on RTD results a new RTD. So the original RTD is not modified, it's immutable. Spark is immutable. The original thing is not modified, right? Yes. Yeah, just observe this, right? So what I'll be discussing as part, like in brief, in depth, we'll be discussing about it, like why PySpark, need for PySpark, PySpark and Scala, real life usage, Spark session, Spark context, parallelizing, repartitioning, broadcast variables, accumulators, RTD computations, operations on RTD, directed Spark follows DAG model, Spark follows DAG, directed acyclic graph model, directed acyclic graph model. RTD's different inbuilt actions and transformations we have got. Steps in RTD computations, RTD persistence. Persistence is also important feature of Spark, I said. Already executed transformations output you can reuse. Persistence features, persistence options, right? Memory only, memory underscore SCR only, disk underscore SCR, memory and disk only option. PySpark core computation, right? Fault tolerance model in Spark, different ways of creating RTDs, creating Spark objects, increasing the number of partitions, aggregations over structured data, groupings and aggregations, single grouping, multi-grouping, single aggregations, multiple aggregations, difference between group by and reduce by key, various inbuilt actions and transformations. So the various inbuilt actions and transformations, you don't need to write huge codings here. PySpark SQL data frame. PySpark, this data frames is one more important thing in Spark, like a tabular structure you'll see. So once you create data frame, you can apply different functionalities. Show, struct type, row, class, column, select, collect with column, column renamed, where, filter, drop duplicates, order by, group by, join, union, UDF, map, flat map for each, pivot, all these things, right? PySpark SQL functions, aggregate functions, window functions, data and timestamp functions, JSON, right? Read and writing, right? And PySpark built-in functions when EXP lit, split, translate, overlay, to date, date format, date difference, explode, array underscore contains, array, collect list, collect set, create a map, map keys, map values, struct, some average row number, rank, dense rank, from JSON to JSON, JSON tuple, right? Schema, right? Working examples. PySpark external sources. Working with SQL statements, Spark and Hive integration. Hive is one of the important component where can be integrated with any other component. And MySQL integrations, working with CSV, JSON, transformations and actions, narrow and wide transformations, adding of new columns, adding of dropping of columns, renaming columns, adding of new rows, handling nulls, creating deployment modes, local mode, clusters mode, PySpark applications, PySpark application, right? Yes. States and tasks, drivers and executors, building Spark applications, pipelines, PySpark streaming concepts, integration with Kafka, and PySpark MLD. So in brief, in depth, we'll be discussing about this PySpark. Yes. Yes. Okay, this is what in brief, in depth, we'll be discussing about all these things, right? Fine. So, yeah. So just I was briefing, right? Yes. Why Spark? It's one of the high-speed processing execution model used for processing huge data. Today, like you see, like huge data getting generated from anywhere. So if you see everywhere, like huge data is every application is generating huge data. Not only for this, even for streaming data, data which keeps on generating, data which keeps on incrementing for that data and
Sir,
use for
you were showing some time, right? I think Yahoo have done some experiment and
yes.
you were showing some. So what was the time like it took for the PySpark?
See, yes, that's what. Okay, 1 second here. So at that time, right, when it was performed test, at that time, her PySpark still Spark wasn't there, right? And it was done when it was done, right, when this test was done. But Hadoop, it was comparing Hadoop with other things, right? When Yahoo has conducted the test around in the year 2014. Right, when Hadoop has got high boom in the market at that time, right? It has got, but compared to this Hadoop, what I'm saying already, Hadoop, what I mean to say here, Hadoop is taking minutes of time, where these are taking days and hours of time. When it is taking minutes of time, then Spark will take how much time when it is 100 times faster than this?
Second, right?
Compare the speed, right? It is taking 3.4 minutes, then 100 times Spark is faster means how much time it takes, you see. That much, that is a very high speed, right? So both Hadoop and Spark, both currently used in the market, right? So Hadoop performs both storage and processing, but for Spark, only thing is the companies which can afford for huge RAMs that they'll be using Spark, otherwise they go for Hadoop. So Spark requires very huge RAMs because your data is going to sit into the RAM, right? It's going to be stored across the RAM and they are processed parallelly. So that's why you
Okay.
see very high speed because of this. See, all these things you can see in Hadoop, all these features, not this one. All these features you can see in Hadoop also, except this in-memory computation feature. Means within the memory level storage and memory level processing, right? That's why you get very high speed, right? And next I'll be discussing about how exactly that's the processing is happening within this Spark. How? And one more thing, you need to clearly understand the important feature, right? One is in memory and one is persistence feature. You have got a very big data flow, which has 40 steps. Means in another task, I got another task in which the first 30 steps are same. The first 30 steps are same. In such case, no need to re-execute the first 30 steps again. The 30th step output I can reuse. I'm saying reusing already executed a transformation output. You have got a very big data flow In that, the 30th step, again, I can reuse and just I can go from 30th to 40. 10 steps only. No need to execute the first 30 steps. 30 steps decreased, right? So that is what persistence. Persistence means making it reusing the already executed transformation output. No need to re-execute. Okay. Fine. So, and there are some things like Spark is in-memory computing. There are some other in-memory computation technologies, right? So, but as compared to, I'll be just briefing why Spark only has got very high speed as compared with other technologies, what advantages you see, and also like RTD's computations and fault tolerance model. Fault tolerance means when your data is running on multiple systems parallelly, there is a chance of any system going down. Then how they will be seeing some data loss and also task failure you'll see. But Spark has got the capability of regenerating the lost data by itself. Okay. And it can compute it. That I'll be discussing. Fault tolerance, right? I'll say multiple cases are there. Case 1, case 2, 3, and 4. What happens if a particular persisted machine is down, persisted RTD machine is down, right? So in brief, in depth, we'll be discussing. From tomorrow, we'll be starting with the actual things. Yes. Any queries you've got? Just introduction to Spark and the features of PySpark. Whenever you say Spark means I'm saying you are implemented with Scala. Whenever you say PySpark, Spark with Python implementation. So yes. And also we can make use of Python like pandas. There is a module like pandas, right? Especially used for this big data environment. So even you can make use of the pandas module of Python for this. It has also got the concept of data frame. It has also got many functionalities where you can also make use of it. Right. Fine. So tomorrow we'll be continuing more on this from where we are stopped. More discussion on this RTD computations, the features of this PySpark. So we'll continue from where we are stopped. Right. Prerequisites for PySpark, right? Yes. So once again, I'm saying what are the prerequisites for PySpark means basic Python, not like advanced Python, basic Python and basic SQL. That's enough. Basic SQL and basic Python knowledge. And basic basic Linux commands. That's knowledge is enough. So those things. Yes. So you can see, you can check in this, right? But today, like PySpark jobs, lakhs of thousands of jobs, right, for PySpark today, because it is one of the demand tool in the market for big data engineers. And also, if you see the salary packages for PySpark also, like 1.5 times more than other technologies, right? But in the same way, they'll be expecting the technical skills from you. So you need to have great command on this PySpark. So everything we'll be exploring all the things with many working examples. Step by step, I'll be showing you all the things. All the sessions will be interactive sessions. You'll be responding for each and everything what I will perform. But even many functionalities, PySpark has got many functions given, right? You need to know about those functions. No need to write a huge codings also. Even if you are implementing with Python, Python is very less coded, very less coding language. Syntactically, it is simple and also involves very less code, right? Yes. So it is a demanding tool, and even you can see a lot of opportunities for PySpark. You can check in the Google, right? PySpark jobs, lot of jobs you see. The package will be higher packages compared with other things, right? Fine. Okay. So session videos, you'll be getting every session video. Even if you miss any session, you'll be getting the session video of it. And you'll be getting this soft copy of this class notes. Some assignments and tasks I'll be providing, right? A WhatsApp group, separate WhatsApp group for PySpark will be created for technical discussions. If you get any error, you can take the snap and post in the WhatsApp group, right? Yes. And interview questions I'll be forwarding you at the last. Okay. And any other queries, right? Tomorrow also same time at 6:30 you can attend the session using the same link to see more discussion, right? Yes. Fine. Okay. So if I'm done with the queries, if there are no other queries, so I'm signing off for now. Meet you tomorrow, same time at 6:30, right? Yes. So it's a weekend batch. So Saturday it will be for 2 hours, Sunday for 2 hours, 4 hours, right? It goes for 8 weeks, 8 weekends, right? Yes.